Okay, let's practice simplifying expressions using trigonometric identities. The things that we want to consider are maybe getting our expressions into terms of sine and cosine only, using Pythagorean identities if we have squared terms and that's helpful, using the quotient identity if we have maybe tangent or cotangent, or reciprocal identities might help us. So what I'm going to do is I'm going to take tangent and use the quotient identity, and I'm going to take secant and use the reciprocal identity to write those two terms in terms of sine and cosine. Tangent of x is the same thing as sine of x over cosine of x. And I'm going to expand that cosine of x as cosine of x times cosine of x over 1. And then secant of x is 1 over the cosine of x. And the reason that I expanded the cosine is because I knew that I was going to need to cancel those cosines that were in the denominator. So the cosine of x and the cosine of x can be simplified to 1 if I divide out that common factor. Same thing here, cosine of x and cosine of x, those can each be divided out to be 1. And then multiplying straight across, this is the same thing as sine of x. Our second question asks us to simplify with no fractions. The first thing I recognize is, okay, there's some denominators here. I want to go ahead and find a common denominator first, and then see what I can do to simplify once I have a common denominator. That means I'm going to need to multiply the right-hand expression by the sine of theta over the sine of theta, and I'm going to need to multiply the left-hand expression by 1 plus cosine of theta over 1 plus cosine of theta. When you multiply this, you might be tempted to expand the denominator, but we don't want to do that just yet in case we might be able to cancel out some terms because, again, our final form wants to be with no fractions. So in the numerator, we get cosine theta plus cosine squared theta plus sine squared theta all over 1 plus cosine theta times sine theta. And when I look in the numerator, I recognize that the cosine squared of theta plus the sine squared of theta is the same thing as a 1. That is a Pythagorean identity. What I'm going to do is I'm going to replace this cosine squared of theta plus sine squared of theta with a 1. That gives me 1 plus the cosine of theta over 1 plus the cosine of theta times the sine of theta. Well, that's nice because then these 1 plus cosine of thetas simplify to 1 when I divide out that common factor. And so I then have 1 over the sine of theta, but my directions say no fractions. And so what I want to do is use that reciprocal identity to call this the cosecant of theta for my final answer. In our next question, we are asked to simplify again using no fractions in our final form. And I see that looking in the numerator, I've got a squared term, which means I might be able to either use a Pythagorean identity or factor. And in the denominator, I have tangent twice, which to me looks like, okay, I want to factor here. And what you might not recognize about the numerator is that this is a difference of squares. If you recall from algebra, whenever you have two perfect squares separated by a subtraction sign, that is the same thing as their sum and their difference as single terms, not their squareds. So it becomes a plus b, a minus b. So I have 1 is a perfect square, secant squared is a perfect square, separated by a subtraction sign. That becomes 1 plus secant t and 1 minus secant t. In the denominator, I have that tangent t common, so I'm going to factor that out. That leaves me with 1 minus secant t. And so I can then cancel the 1 minus secant t's. I then have 1 plus the secant of t over tangent of t. And in this case, what I can do now is separate this into two separate fractions because I have one denominator. Let's say if I had like 1 plus 2 over 3, that's the same thing as a third plus 2/3. So I can separate this to be 1 over tangent t plus secant t over tangent t. And the reason that I want to do this is because I'm then able to break it down even further. The 1 over tangent t, I can either use the reciprocal identity to say that that's cosine of t, or you could rewrite it using sine and cosine. I'm going to rewrite secant using the reciprocal identity and tangent using the quotient identity. That's going to help me simplify because remember the whole goal is no fractions. If we were allowed to have fractions, we might want to leave it as 1 plus secant t over tangent t. This is the same thing as cotangent t plus 1 over cosine t divided by sine t over cosine t. And if you can't see the cosine simplify at this point or what you would get, you would want to multiply by the reciprocal. That's going to give you the cotangent of t plus 1 over the sine of t, which using the reciprocal function is cosecant t. So we have cotangent t plus cosecant t as our final answer. Now we're going to be verifying an identity rather than simplifying an expression. And we see some negatives in here, which to me means, hey, I want to use some even and odd properties. Remember that cosine and its reciprocal are the only two even functions. The rest of the trigonometric functions are odd, which means that cotangent is odd and sine is odd. And when you have odd functions, when you input a negative, that means that the function itself is a negative. Recall that the sine of negative x is equal to the negative sine of x. The cotangent of negative x is equal to the negative cotangent of x. So I'm going to rewrite that saying I have the negative sine of x and the negative cotangent of x all over the cosine of x equal to 1. And then that helps me because I can then say a negative times a negative is a positive. In addition, I'm going to separate this a little bit just to make it a little bit easier to see. This is the same thing as the sine of x over the cosine of x times the cotangent of x equals 1. And I can rewrite cotangent as cosine of x over sine of x. I then have sine of x over cosine of x times cosine of x over sine of x equals 1. The cosines divide through and the sines also divide through, so that simplifies to 1 equals 1, which does verify that identity.